Hello, good evening everyone. Today is our fifth lecture of the NPTEL course Introduction to Algebraic Geometry and Commutative Algebra. So today's topic is linear independence, relation sum modules and tree modules. Uh, so let us start with our first problem, that is problem 5.3 from your assignment sheet. Let AB belongs to n star, that means all the natural numbers, and let D equals to GCD of AB, the greatest common divisor of A and B. Then the relation sum module denoted by REL suffix Z bracket A comma B equals to x comma y coming from Z2 such that xa plus yb equals to 0. Is generated, this is the relation sum module, is generated as a Z module by BD inverse comma minus AD inverse from Z2. So we have to prove that this relation sum module is generated as a Z module by this kind of elements. So you see that your A and B is fixed. What is varying is D. No, D is also fixed, that is the GCD of AB. So what you see is that this is generated by this single element. So we have to prove that. Now, since D is the GCD of AB, we can write A as D into A prime and B as D into B prime. With GCD of A prime, B prime equals to 1. That is true, right? You can just divide A by D and B by D, and you get your A prime and B prime. Now let x comma y of Z2 satisfy xa plus yb equals to 0. Then D of xa prime plus yb prime equals to 0. Since we have assumed that xa plus yb equals to 0, and hence xa prime plus yb prime equals to 0, and since GCD of A prime and B prime equals to 1, it follows that that your A prime divides y and B prime divides x. How does this follow? Now, since so this would imply x A prime equals to minus of y B prime. Now you see that A prime does not divide B prime, but A prime divides y B prime. So A prime has to divide y, and in a similar fashion B prime has to divide x. Thus there exists k coming from Z such that x equals to kb prime and y equals to minus ka prime. Therefore you have x comma y equals to k of b prime minus a prime, and which equals to coming from this and this, k of bd inverse minus ad inverse. I mean, one part is done, that is every element coming from this is a multiple of this, and conversely every multiple of this clearly satisfies that xa plus yb equals to 0. Hence this is generated by bd inverse comma minus ad inverse. Now go into our next problem, that says that in the subspace U defined as summation of r of sine x plus a, that is generated over r by sine of x plus a, of the R vector space R to the power R of all functions from R into itself, generated by the functions sin x plus a, where a is coming from R. Okay. Show that the two functions sin x and cos x form a basis of U. In particular, R dimension of this vector space is 2. Now you can take 5 minutes to understand this problem, then we will start solving this.
To the boundary.
That's a very good shot. A man in form, little width, played it over the fielder purposely. And outfield is very fast. Anything in the gap will race away to the boundary.
There's a little bit of shape there. I think he can go a fraction fuller while this ball is swinging, just a bit.
And pitch looks really good. We are into second over, good bounce, even bounce. And this is the Pakistani squad. One change, Shaheen comes in for Fahim Ashraf. I think that's a very good decision on this pitch. Another pacer.
Pulled straight to the sweeper.
Yeah, I agree with you, Nas. He needs to be a little fuller. Pitch looks good, is fresh. And the management was out there and they're really looking at it closely and before they decide what they need to do, and Pakistan decided to bat first. There's a little bit of bounce, should come onto the bat nicely.
Yeah, the groundsman was walking along and bouncing a ball on it, and it was bouncing up chest high, so it's got good bounce. Don't get carried away with it as a bowler though. Beautifully clipped. Should only be a couple.
That's a very sensible start from Saim Ayub. Boundary in the first over against Jofra Archer, and then playing along the ground, down leg side, getting his rhythm back, his momentum back. He is a very, very good player, no doubt. Very talented individual.
Real number A, we have the trigonometric identity.
Yeah, he likes it on his legs. The only issue there is he sometimes closes his bat face too early.
Plus cos x into sin A.
If he looks to play more squarer, he feels really good. That's a good pacey delivery, 145.4 kilometers an hour.
So that's what we were talking about earlier on. As you can explain it. Now this particular delivery, you should have played it straight towards mid-on, not towards square leg or mid-wicket, am I right?
Yeah, you got to remember it's T20 cricket, so there is always a risk, and with the shape he'll pick it up. The shot against Archer was high risk.
So that means cos x belongs to you also.
That will be a wide.
Therefore, span of sin x,
especially when you're out of touch, especially you've been unlucky, and then obviously you need your form back. You know you're a quality player.
E equals to span of
So far the pitch played beautifully.
sin x,
Pitch report
cos x
I think
over
by
r.
Ramiz and Morgan.
Therefore,
They said it's a really good pitch, bit of extra bounce there. Extra bounce metal will come nicely on the bat.
Beta of cos x equals to 0 for all x belongs to r. Evaluating at x equals to 0 yields that sin x is 0 and cos x is 1. Therefore, beta equals to 0.
Just a fumble out there. They think of 2 and they don't risk it on Bethel's arm. It's 14 for none after 2.
Sin x and cos x are linearly independent and it forms a basis.
Only 15 days to go. My line still gets messed up under pressure. What do selectors actually look for?
Selectors first look for consistency. Focus on hitting the same line and length. Keep tracking your accuracy. Control will come with it. Should I create a 15-day line control training plan for you?
take
all glued to the TV right now.
Up in the air, it should go to the man in the deep, it does. Archer with the celebration he's used here in Pallekele, and Saim Ayub causes pain in the crowd.
Plan worked, pace worked, and that's what exactly they were hoping for England side, especially Jofra Archer. There was a plan, bold shot, going away, top edge, he wasn't in control.
Okay, so let us start solving this. Let V be a non-zero Q vector space, and viewed as a Z module, V is divisible. That means for any vector from this vector space V, small v, and any non-zero integer, the element W defined as V by N satisfies NW equals to V, and suppose for contradiction that V were free as a Z module, then V would be something as some power of Z for some index set I, and for any integer n greater than equals to 2, multiplication by n is not surjective on Zi, right? Because Z does not have this divisible property, and since no basis element is divisible by n, what I was saying, and hence a non-zero free Z module is not divisible. Yeah. So therefore this contradicts the divisibility of V, and yeah, therefore V is not free as a Z module. I mean I mean, what the main mantra is of this solution is that uh, V is Q vector space, therefore V is divisible as Z module. But if V was free as Z module, then it will not be divisible over Z. So this is the contradiction. Now we'll focus on the next problem that says that let small n belongs to capital N and K be a field, and let x1 to xn plus 1 be elements of a K vector space V, and suppose that some n of them are linearly independent. Then we have to show that this K dimension of this relation set is 1, and we define relation set as in the problem 1, that means all the tuples from your index set such that this sum of the products is 0. So here it should be it was from Z module, yeah, and here since it is K, so the elements are of the form a1 dot a n plus 1 coming from K to the power n plus 1 such that xi ai is 0, and we have to show that the dimension of this set is 1. Okay, so you can try this for 5 minutes and then again you can start it. Okay, so let us solve this problem 5.6a. Now, since some n of the vectors are linearly independent, we may reorder them and assume without loss of generality that x1 to xn are linearly independent. Then xn plus 1 lies in the span of x1 to xn, and so there exist unique lambda 1 to lambda n of k such that xn plus 1 equals to lambda 1 x1 plus up to lambda n xn. And rewriting, we obtain the non-trivial relation, that is lambda 1 x1 to lambda n xn minus xn plus 1 equals to 0. Hence lambda 1 to lambda n minus 1 belongs to this set relation of x1 to xn n plus 1 over k, and let a1 to a1 plus 1 belongs to this set. Then a1 x1 plus up to an xn plus 1 xn plus 1 equals to 0. Substituting the expression for xn plus 1 gives a1 plus an plus 1 lambda 1 of x1 plus up to an plus 1 lambda n of xn equals to 0. Since x1 to xn are linearly independent, all coefficients vanish, and ai equals to minus of an plus 1 lambda I. Thus, every relation is a scalar multiple of lambda 1 to lambda n minus 1. Therefore, the dimension of this is 1. And now if you look into the next problem, that says let a1 to an of k be pairwise distinct and set gi equals to a1 of v which belongs to k to the power n. Then g1 to gn are linearly independent over k. Again, try this for 5 minutes and then we can start discussing this. Okay, so let us solve this. Assume for contradiction that G1 to Gn are linearly dependent. Then our aim is to show that they are linearly independent. Then there exists a non-zero vector b1 to bn such that b1 g1 plus up to bn gn equals to 0. That means for all v of n coming from n, b1 of a1 v and bn up plus up to bn of n v is 0. Hence b1 to bn belongs to a relation set of g1 up to gn. By part A, the relation subspace over K is one dimensional, so it is spanned by b1 up to bn, and consider the vector b1a1 comma up to bnan, and for all v belongs to n, b1a1 up to v plus 1 plus bn an up to v plus 1 equals to 0, and so b1a1 comma up to bn an is also a relation. Hence there exists lambda belongs to k such that b1 an comma up to bn an equals to lambda of lambda into b1 up to bn, and for each I bi is non-zero. This implies ai equals to lambda for all I. Since the ai are pairwise distinct, at most one of bi can be non-zero, contradicting that b1 comma to bn is a non-trivial relation. Thus g1 comma up to gn is linearly independent. So we are done. Now let us move on to a third problem that says if I is an infinite set, then we have to prove that dimension of ki over k equals to cardinality of k to the power I. So take your time and we will meet after 5 minutes. So I was trying to explain it, but since none of you are attending the class online, therefore I don't know which part may you might get doubt. So I just don't explain much rather than what I wrote to tell you just. Okay, so let us solve this. Now one side is clear, right, that dimension of a vector space or dimension uh, um, of a vector space is always less than equals to the cardinality of the space, right? And what was your k? K was a field, right? So yeah, so to prove the reverse inequality, choose an injective map from natural numbers to I, and for each small a of k, define GA belongs to k to the power I by GA of sigma v equals to a to the power v, where v is coming from natural numbers, and g of a of I equals to 0, where I is coming from I minus image of sigma. Now by part B, the family GA, where A is coming from K, is linearly independent over K, and hence your cardinality of K is less than equals to dimension of K, K to the power I. Since I is infinite, we have that K to the power I mod of K to the power I is greater than equals to mod of K, and therefore we have K to the power I less than equals to dimension of K to the power I over K, and combining both inequalities gives us this. Now the next problem is our last problem. So you can take 10 minutes to understand this problem, then we'll discuss this and finish this lecture.
अगर आपको लगता है कि हम अच्छा काम कर रहे हैं तो सपोर्ट कर, 1 रुपए देकर आप इस चैनल को सपोर्ट कर सकते हैं। इंफ्रास्ट्रक्चर प्रोजेक्ट्स का वीडियो देखा है, कभी नॉर्दर्न रीजन, कभी वेस्टर्न रीजन, तो कभी सदर्न रीजन ऑफ इंडिया, बट वी हैव नेवर एक्सप्लोर्ड द नॉर्थ ईस्ट। तो इंफ्रास्ट्रक्चर प्रोजेक्ट की सबसे लंबी रिवर रही है और 15 किलोमीटर, लेकिन जो 2 स्टेट्स आसाम और अरुणाचल प्रदेश को कनेक्ट करती है। लेकिन अगर मैं बोलूं कि बहुत ही जल्द ये देश और एक ब्रिज का काम चालू है, जिसकी कंप्लीशन के बाद इट विल बिकम द लॉन्गेस्ट रिवर ब्रिज ऑफ इंडिया विद धूबरी फुल है, वो भी है। चैनल को सब्सक्राइब जरूर, वीडियोस को। थर्ड विजिट इन दिस रीजन, बट दिस टाइम हैव टू से, खैर अगर आपको
Defeated by arch rivals Inter in Serie A and then hammered by with Como's last victory in Serie A coming in late underway. It's vital that Juventus bounce back, isn't it? Manuel Pascali, hello.
Hello, Thomas. Yes, of course. They have to respond immediately.
Commanders immediately goes long. McKennie.
Been on, lost themselves in front of their own fans.
Okay, so let us start discussing the problem. That xy belongs to z to the power n for small I belongs to capital I be a family of integer intervals, and for a prime number small p, let fp denote the prime field of characteristic p. Then what they say is that the following statements are equivalent. The first statement says that the vector small xi, where I coming from capital I, are linearly independent over z. The images xi, so this is the first statement, and the second statement says that the images of xi was in Qn are linearly independent over Q. Okay, and there exists and the third statement says that there exists a prime number p such that the images of xi in f and p are linearly independent over fp. And the fourth statement says that for almost all prime numbers p, the images of xi, small I coming from capital I, in f and p are linearly independent over fp. So yeah, these are the four statements, and the fifth one says that if I is finite with cardinality of I is n, then these statements are further equivalent to the fifth statement, which says that there exists a non-zero integer m such that m of zn belongs to z of xi, such that this small I belongs to capital I. Okay, so what we try to do is that at least show that the first statements are equal. So the first will go to 1 to 2. That means that if xi are linearly independent over z, then xi are linearly independent over q also. So assume that the xi are linearly independent over z, which the first statement says that, and suppose that qi summation of qi xi equals to 0, with qi belongs to capital Q, I mean the rational numbers. Choose a common denominator d coming from z, such that dqi belongs to z for all I. Just take the GCD of all the denominators, and multiplying the relation by d, we obtain this, that is summation of dqi xi equals to 0, which is an integer linear relation, and by linear independence over z, all coefficients dqi vanish because these are linearly independent over z. Hence qi equals to 0 for all I, and thus the images of xi are linearly independent. Now we will try to show that the 2 belongs to 1. That means if xi are linearly independent over q, we have to show that xi are linearly independent over z. So conversely, assume that xi are linearly independent over q. Now if there were a non-trivial integer relation AIXI equals to 0 with AI belongs to z, then the same relation would hold in Qn and contradicting the linear independence over q. Hence this is satisfied and we are done. Now we'll look into 2 imply 4. So 4 says that for almost all prime numbers p, the images of xi are linearly independent over fp. So assume that the images of xi are linearly independent over q. Now if we choose a finite subset j over j coming from I, and from the integer matrix that says that m equals to xi, where I belongs to capital J, belongs to m of n across cardinality of z, that is the integer matrix of order n cross cardinality of j. Now linear independence over q implies that some square submatrix of m has a non-zero determinant delta which belongs to z. Now for any prime p not dividing delta, the reduction of this submatrix modulo p has non-zero determinant in fp if p does not divide delta. Hence the corresponding vectors remain linearly independent over fp, which what I am trying to say is that since only finitely many primes divide delta, the vectors are linearly independent over p for almost all primes p. So what we are trying to say is that if images of xi are linearly independent over q, then this integer matrix what we are forming, because xi are coming from q to the power n, so therefore they do form a matrix, and from here I mean this non-zero determinant over q it has, and if this non-zero-ness passes to the over fp, then you will say that these entries are also linearly independent there. So this is exactly what happening there. And for the option 4 to 3, we will show that but this is not that non-trivial, because if the vectors are linearly independent over fp for almost all primes, then they are linearly independent at least over one prime. So this is trivial. Now for 3 implies 2, assume that there exists a prime p such that images of xi in f and p are linearly independent. And suppose we say that the images in qn are linearly dependent. We will show this by contradiction. Then there will exist a non-trivial rational relation which is summation of qi xi equals to 0, and clearing denominators will yield a non-trivial integer solution, that is summation of ai xi equals to 0. And reducing this relation to modulo p produces that a non-trivial relation in f and p contradicting the assumed linear independence. So therefore our images has to be from here, if summation aixy equals to 0, you can just take out the smallest power of p, which divides all of the ai, and then you will see that at least one term has non-zero entity in f and p, right? That is what we are seeing, is that would contradict the assumed linear independence over f and p. So yeah, we have shown that 1 to 4 are equivalent. Now equivalence with 5, and we show that what if I is finite. So assume I equals to second bracket 1 to n, and set your L as summation of z xi which is a subset of zn, z to the power n. And if the vectors x1 to xn are linearly independent over q, then L has rank n and hence finite index in z to the power n, right? Because if these are linearly independent over q, these are linearly independent over z, so therefore yeah, L has rank n, and therefore there exists a non-zero integer m such that m of z to the power n belongs to L, and conversely if such an integer m exists, then L has rank n, which implies that the vectors x1 to xn are linearly independent over q. Thus what we have shown is that B is equivalent to 2, that is the vectors, the images of xi in q to the power n are linearly independent over q. So we have shown this case also. So we are done. So actually what we are doing, okay, give me 2 minutes. Okay, so what I was saying is that these questions, the solutions I have written are fairly readable to you. So yeah, so if you have any doubt, again you can mail me the mail address. So I hope you understand this. Okay, so let us meet on next Tuesday. Thank you.